to the 22nd lecture on probability and statistics, and in this lecture we'll start chapter number 4, and in the upcoming 3 or 4 lectures we will keep on studying chapter number 4, which is about probability and probability distributions. So probability is the measure of chance. Probability is a tool for the statisticians like you. It tells about the reliability of your estimates. For example, if you toss a coin a large number of times, and if you toss a coin for a very large number of time, it comes out that you get 50% heads and 50% tails as a result of a large number of trials. Then you have some information about that coin, and then what is the probability or chance that if you are going to toss it once more after you have developed a conclusion about the coin by tossing it a large number of times, and then you are going to toss it once again, then what is the chance of getting a head? Well, that's a simple question. What is the probability or chance of getting a head, given that it was a fair coin and you found this out by tossing it for a very large number of times? So what should be your answer? That what's the chance of getting a head? Of course, 50%, and that 50% we call it 0.5 probability. So chance or probability, it tells us about the reliability or the accuracy of the estimates we make about the population. When we toss the coin a large number of times and we accumulate an information about it that it is 50%, it gives us 50% heads and remaining 50% tails, then we actually uh, accumulated a population, a data for population. That is actually the population that we tossed it for a very large number of times, and then the conclusion was that it's a fair coin. It gives 50% heads, 50% tails. So now when we toss it once more, single trial means toss it once more, this means that is a sample, right? So this is the difference between the population and sample. Tossing the same coin for a very large number of times and building a conclusion about it that it gives 50% heads and 50% of the times it gives tails. It gives a tail. This means you have accumulated the data about the population. That is the population, and tossing it once more is a sample. So this sample with the outcome of this sample, or once more or 2 or 3 times more, is a sample. So the probability helps statisticians in 2 ways. Given population, it gives you an idea about the likelihood of observing a particular sample like this. Given this population, like we did in this last example, we tossed the coin for a very large number of times, and our conclusion was that it gives 50% heads, 50% tails. So when we're going to toss it once again, what should be your guess? What should be the likelihood of observing a particular sample? Means, for example, head. Of course, 50%. So given population, you can guess about the likelihood of observing a particular sample observation or measurement. And the other way it helps is that given a sample, it gives you an opportunity to calculate parameters of population, like we did in last chapter number 2, when we collected a sample and we computed its mean, and we said that if it is a random sample, its mean is a measure, or is an estimate. The sample mean is an estimate of the population's mean. So in these 2 ways, number 1 and number 2, in these 2 ways, probability helps statisticians in making guesses about either sample or about population, given the other quantity. Right. So in this lecture, we are going to study a few more terms that are event, experiment, simple event, event, mutually exclusive events, sample space, and Venn diagram. So these are some important concepts we're going to study in this lecture. Event, but before we study event, let's talk about experiment. It's a process of obtaining a measurement. For example, measuring rainfall, recording CGPA of a student is an experiment. Tossing a coin is an experiment. Rolling a die is an experiment. A simple event is the outcome of a single repetition of the experiment. For example, the output of tossing a coin, either head or tail. So it's a simple event. It's not event, it's a simple event. In the case of a die, rolling it gives us 1, 2, 3, 4, 5, or 6. So these events E1 to E6, they're also simple events because they are obtained by by and these are actually the outputs of the experiment or outcome of a single repetition of the experiment. So the experiment was to roll a die, for example. Right. So the experiment is to roll a die. What should be the single? What should be what are the set? What is the set of possible single simple events? Of course, they are E1 to E6, 1, 2, 3, 4, 5, 6. Right. Event is a bit more complicated. It's the collection of simple events. For example, for this die, we have these simple events E1 to E6. If someone asks what is the probability or chance or the event, what is this event? Observing an odd number, right? This is also an event, observing an odd number. What about these events, simple events? Observing a 1, observing a 2, 3, 4, 5, or 6. So what is this event A? Observing an odd number. This set should contain what? E3, E5, E1, E3, and E5. That's simple because these are the three odd numbers in this set of simple events. And for B, it's E1, E2, and E3 because AB is an event of observing a number that is smaller than 4. So this should be E1, E2, and E3. Mutually exclusive events are the events that cannot occur. Both A and B above are they mutually exclusive? Can they occur simultaneously? Yes, they can because E1 is here as well as it is here. So we have common simple events in these two events A and B. So we have 1 and 2. We have two simple events common in sets A and B. Therefore, they are not mutually exclusive. They are not. They can happen simultaneously. Then what can be an example of events that are mutually exclusive? Mean they cannot happen, they cannot occur simultaneously. What can be? In the next line, I'm going to give on the same example. Observing an even number. Now, what is A? Event A is observing an odd number, 1, 3, or 5. C is observing an even number. So A and C are mutually exclusive because the outcome can either be an odd number or it can be an even number. It cannot be an odd or even number simultaneously. It can be either an odd number or an even number. So A and C events are mutually exclusive, but A and B are not. They are not. So A and B are not mutually exclusive because they can happen simultaneously because we have terms common in A and B. The terms are E1 and E3. So these two common terms. So the outcome can either be, and one outcome can simultaneously be an odd number or a number that is less than 4. For example, 1. If you toss a coin, you get a 1. That is an odd number, right? That is an odd number. as well as a number less than 4. So these two events are not mutually exclusive. They can happen simultaneously. They can happen at the same time. They can occur at the same time. So they are not. But A and C are, of course, mutually exclusive. Sample space is a set of all simple events, right? This is one more definition. Sample space is a set of all simple events, not events, not events. Simple events means, what are simple events? For a die, these are E1, E2, E3, E4, E5, and E6. For a coin, these are E1 and E2. Simple events, not events. So that's important. That's important. For a sample space, it's a set of all simple events, not events, right? Not events, but simple events. This you should remember, simple events. So Venn diagram is the last thing that we will study today. Venn diagram, a graphical representation of events or simple events. We draw everything here on this in this box, this blue box. In this blue box, I have drawn this blue box for a dice roll. We have 6 simple events, and I've drawn all 6 simple events here. And now I'm going to plot A and B. So with this green color, I have drawn A, and with the brown color, I have drawn B, and I forgot to write B here. So what should I do? I think I should use the red color or for drawing. Right, let's find out brown color from here. Right, I got it. B. So this is B. This brown is B. This brown is B. So in A and B, what do you think? What two events? Which two events are common? Simple events. E1, this one, and this one, E3. So these two events are common. So if we have common simple events in two events, they cannot be mutually exclusive. But there's a homework for you. Draw a Venn diagram VD, Venn diagram VD for events A and C. A and C, and you'll see they won't overlap. This means they are mutually exclusive. So that's all for this lecture. We'll continue studying probability and probability distributions in our lectures to come. Thank you.